differentiation of trigonometric functions. So just as a note, we make sure we remember that radian measure is always used when we're differentiating trigonometric functions. So we have our basic derivatives here. d on dx of sine u becomes cosine u multiplied by du dx. So we differentiate our u inside here. d on dx here of cosine of u is equal to negative sine of u multiplied by du on dx. Then working on these, we can find the derivatives of the remaining trigonometric functions. So these are all on your actual formula sheet here. So we have here d on dx of tan u is equal to sec squared u multiplied by du on dx. d on dx of sec u here is sec u tan u multiplied by du on dx. d on dx of cosec u is equal to negative cosec u cot u multiplied by du on dx. And d on dx of cot u is equal to negative cosec squared u du on dx. So we want to differentiate the following here. So here we're going to start off here, our actual rule that we have, d on dx here, cosine of u is equal to negative sine of u du on dx here. So here we've got cosine of 2x plus 3. So u is equal to 2x plus 3. du on dx, differentiating in respect to x, will be 2. So going over here, we're going to say, well, dy on dx is going to be negative sine of u, 2x plus 3. So we've done this part, multiplied by du on dx is 2. So here it will be minus 2 sine of 2x plus 3. So moving to our next example here. So we write out our rule to start with here. We've got d on dx of sine u is equal to cosine of u du on dx. So here we've got u is equal to 2x squared plus 3. du on dx here is 2 times 2 is 4x. And our 3 disappears. So now we go over here and say dy on dx. First of all, our sine u becomes cosine u. So cosine of 2x squared plus 3 multiplied by du on dx multiplied by 4x will become 4x cosine of 2x squared plus 3. Okay, so looking at our next question here, we want to find some little bit more complicated ones. We're going to have to bring a couple of rules into this. So we'll start with writing out our rules that we know over here. We've got d on dx of sine u is cosine of u du on dx. So in this case, u will be, with our sine u, 3x here. Or we'll work through it step by step. We'll work through it in the problem here. So we're going to say, well, here dy on dx. And here we've got two different ones. We're going to be using our chain rule. So here we're looking at, well, we're going to be working through, so our chain rule, so our d on dx of u multiplied by v is u times dv on dx plus v times du on dx here. So we're going to start with, okay, so here sine of 3x multiplied by our u of dv on dx. And so here we didn't write through here our cosine rule as well. So here d on dx of cosine of u is equal to negative sine of u du on dx here. So our next part, so our sine of 3x multiplied by a differential of our cosine here. So here cosine of 2x becomes negative sine of 2x multiplied by du on dx, which becomes 2 here. Then our next part will be our v. So our v is our cosine of 2x multiplied by our du on dx. So here our sine 3x here becomes cosine of u du. So cosine of our u is 3x multiplied by du on dx. We differentiate 3x and we get 3 here. So we're going to end up with 2, so negative 2. Negative, and we have a 2. And then we've got sine of 3x multiplied by sine of 2x. Then here we've got plus 3 cosine of 2x multiplied by cosine of 3x here. So looking at our next example, again we're going to start out with writing our rules that we know up here. So d on dx here, so sec of u becomes sec u tan u du on dx. And here d on dx of tan u is sec squared u du on dx. And again we're going to be using our chain rule. D on dx of u times by v is our u times dv on dx plus our v times du on dx here. So working through this, we differentiate dy on dx. So here we're going to start with our u, so sec of 2x. Then we're multiplying it by here our v here, differentiated here. So tan of 3x becomes sec squared 3x multiplied by du on dx. U is equal to 3x, so that will become 3. Then for our second part, so we've done this part here. Our second part is v. So our second part here, tan of 3x multiplied by du on dx. So we differentiate our sec 2x. Becomes sec 2x tan 2x multiplied by du on dx, which we differentiate the 2x, becomes multiplied by 2. So writing this one out here, we get here 3 sec 2x sec squared here 3x plus 2 tan 3x sec 2x tan 2x here. Okay, so keeping on working through this one, here we're going to be bringing together more of our rules again. So here we're going to write out the rules that we do know that are involved. So here d on dx of sine u is cosine of u du on dx here. And we write it out, so y is equal to sine of 2x minus 1 to the power of a half. So to work through this one here, we multiply our half down, we're going to have a half u and minus a half, so here a half sine of 2x minus 1 to the minus a half here, subtracting 1 from a half, times, here differentiate, here sine of 2x minus 1. So here we can write this out, this becomes 1 on 2 root sine of 2x minus 1 here multiplied by here, and so if we differentiate our sine 2x here will become cosine of 2x minus 1 multiplied by, so we differentiate our 2x minus 1 will give us 2. And here we can write it as a fraction over 1, so we can just try and skip a step in here. So here at the top of our fraction we're going to have 2 cosine of 2x minus 1 divided by 2 root sine of 2x minus 1. Our 2's will cancel, so it becomes cosine of 2x minus 1 divided by square root of sine 2x minus 1. So keeping on going to exercise A. Working through more of these problems here. So we're going to write out what we need to know up here. Our formula d on dx of tan u is sec squared u du on dx here. So we're differentiating over here dy on dx. We have two separate terms here, and we're going to say, well, here before we start, we'll try and take this out, make it a little bit easier. We've got tan of x plus a third times tan of x cubed. So here we can differentiate our tan of x. Here that just becomes sec squared x, and then our du on dx we differentiate x and we get 1, so multiply it by 1. Now we have our second part of our fraction over here. So bring our 3 down, so here it'll be a third multiplied by 3 tan of x, and we subtract 1 to the power of 2, so squared, multiplied by a differential of our middle part here. So here our d on dx of our tan of x here. So this becomes sec squared x plus a third by 3 is just gives us tan x squared, we'll keep it in this format at the moment, multiplied by here, we want to differentiate our tan of x, so we're using this equation up here again, will become sec squared x multiplied by differentiating of our x becomes 1 here. So it ends up being sec squared x plus tan squared x multiplied by sec squared x. So moving to our next equation here, we start again by writing out our relevant formulas at the top here. So here d on dx of cot u is equal to minus cosec squared u du on dx here. So here dy on dx, here we've got cot of 2x, so it'll be minus cosec squared 2x multiplied by, we differentiate now our u, which is our 2x, multiplied by 2. So this will be equal to minus 2 cosine squared 2x. Looking at our last problem here, this is a simple one to go through here. We write out our formula, d on dx cosec of u is equal to negative cosec of u cot u du on dx. And here our u is just x here. So dy on dx here is minus cosec of x multiplied by cot of x multiplied by, we differentiate our x, will give us 1. So here it's equal to negative cosec x cot of x.